Okay. Everyone, sorry for that delay, but let's get started. I have with me our first, I guess, real writing. So you might want to flex your wrists a little bit, get them stretched out, do what you need to do. We might write a little bit more than usual today, but it's all based on practicing different kinds of questions. So let's just read very quickly. I'll summarize. In grade 10 and grade 11, you were always solving for x by either factoring of algebra or the quadratic formula. That was it. Whether you understood what you were doing or not, you were just constantly factoring and doing quadratic formula. I want to try to explain to you, using a variety of different examples, how what you were actually doing if you didn't understand why you were doing it, and how that will help us at the grade 12 level solve these kinds of questions. Okay. First off, there will always be polynomials that you still cannot factor. You still won't be able to factor, just like you didn't have you weren't able to factor some examples in grade 10 and grade 11. So in times like this, so sometimes you will have to use technology just to confirm or just to figure out what that is. What am I talking about? Let's backtrack. Questions in math will always just say solve. That's it. But with all your training, I hope you understand what that means. Any thoughts? If I give you an equation, I say solve. It's not when x equals 0 or anything, something more than that. Cecilia? No? Okay. Not, well, yeah, mostly. Almost all the time, you would imagine solve for what is the x-intercept, right? Normally, that would be the case. But that's not exclusive to the word solve. Solve means something even more, and usually it means solve for the x-intercepts. What does solve mean in mathematics, or in this case? Can I tell you? Solving for the variable, yes. Solve, so solve means solve for x, but what? Solve for x when? Solve for x why? Like it's a question that you need to ask yourself. If you don't quite understand, then you're going to end up memorizing all 4 different kinds of examples, which I don't want you to do. When the math question says solve, it means solve for x that makes this sentence true, or that makes this equation true. That's what it means. And so when Cecilia says solve for the x-intercept, yes, it's solving for x when the y value is a 0. You get me? But I can just as easily say solve when x cubed minus 4x plus 2 equals a 2. Now that's not the x-intercept, but I still want you to solve for x that makes this true. Okay? So let's take a look. I am going to shamelessly ask you to jog your memory for your integral 0 theorem. If you wanted to solve for this, the easiest way is to factor, right? Well, I didn't give you any factors. So what do you think? What could you do? What x values or what factors can I test? Right? Yes, factors of 2, right? What are the factors of 2? I'm going to highlight it. Yep. Good? All right. So I'm going to spare you the pain. I'm going to do it for you, okay? I'm going to call this f of x, just for simplicity's sake. F of 1 is 1 cubed minus 4 times 1 plus 2. That is not a 0. Okay. F of negative 1. Negative 1 cubed is negative 1. Negative 4 times negative 1 is plus 4 plus 2. That is not a 0. F of positive 2, that's an 8 minus 8 plus 2, not a 0. F of negative 2, negative 8 plus 8 plus 2 is not a 0. What? What does that tell me? What does this tell me? Did I miss a number? Not according to the theorem. Lucas? It's not factorable, yeah. Not factorable, at least algebraically. So does that mean no x-intercepts? You have to check. I'm going to use technology. Since we can't do it by writing, let's take a look at what it looks like. Because how do I know there must be an x-intercept? At least one. How do I know that? Huh? Yeah, it's got to do that. It has to cross that line somehow. But I can't factor it. So what's the deal? Well, I've got Desmos with me. I'm going to plug in x cubed minus 4x plus 2. Here we go. We got y equals x cubed minus 4x plus 2. Look, so I still have x-intercepts. Let's take a look a little deeper and see what points they are. Well, that's not pretty. I wouldn't expect you to get that algebraically. I understand. So here's an example where you have no choice but to use technology. I copy these numbers down somewhere, so I have these. So you can say, using tech, resolution, the zeros are what was it? A negative 2.21, positive 0.54, and a positive 1.68. You got no choice. And even if I write this, is it 100% accurate? Oops. No, right? Because there's more, I rounded that. There are more decimals. So if I wrote f of x is equal to x plus, this would be technically wrong. It's not exact, right? So it's not quite equal to this. It's, I rounded it. Not exact. That's the I guess the beauty and the flaw of technology. Yes?
For this question, can we factor x and say it's power 2 minus 4? And then we'll get,
you still have a plus 2. So the question that Leon was asking is, can I partially factor an x out, leaving me x squared minus 4, and then plus 2 equals a 0? You could do that, but remember, this has to equal a negative 2. It's not actually zeros that we're looking for. So it gets really, really complicated, right? We're not looking for a 0. We're not looking for x-intercepts because there is a number here. And so we can't quite do that. This function is not something that we can factor. So let's take a look at a question where we can factor. But it doesn't look that way. Here's another example where you're going to have to do some algebra. The question still, as always, says solve. Solve for x that makes this statement true. Well, that's a little hard, isn't it? Are you going to guess and check? No. I'm sure your teachers have, slapped you on the wrist for guessing and checking. We're going to simplify this so that we can use the tools we have all this time. Why not? You spent so much time and effort learning these techniques. Why not set it up so you can use them? I am going to rearrange. Okay, so I'm going to use algebra to subtract both sides by x minus 3. Sorry, x power 3, which brings me 1x cubed. I'm going to add 2x squared to both sides, which brings me negative 3x squared. And I'm going to add 7 to both sides, leaving me with a negative 3. So plus x minus 3. And all of a sudden, what did you create? It's a cubic that equals a 0. So this should be familiar. So now that this is familiar, use your past skills. Let's factor it. What would you do at this point?
Factors of 3.
Yes, you could. Now I'm going to cheat. This example said there was group factoring. So sometimes you don't have to go that far. Sometimes the numbers are nice so that you can do group factoring from when you're a kid. You can always do factor theorem as well, but let's work on this. If I factor out an x squared, I get x minus 3 plus, and then I have x minus 3. I hope you see where this is going. This becomes x minus 3 factored out, leaving me with x squared plus 1 equals a 0. So if x minus 3 was the 0, x must equal a 3. If x squared plus 1 was the 0, then x squared would be a negative 1, which means x does not exist because you can't have square root of negative 1. Should I write that a little bit better? If x squared equals negative 1, then x equals plus minus square root of negative 1, which does not exist. Maybe that's better. So what does this mean? Pop quiz. So x equals 3. What does that mean? Does it mean, oh, it's a cubic, so at x equals 3, it must be something like that? What does it mean? Okay, what does it mean? Katie?
I have 2 guesses.
Okay.
One is that it only would have 1 root. The other one would be that I don't know what this would actually mean, but it seems to have a complex.
Well, yes, this is a complex number, which we're not going to talk about in a Cartesian plane of x and y. But yes, you're right with how you describe this. X equals 3. There is only one root, aka only one solution to this highlighted equation. But what does that mean?
I have a question.
Oh,
Is
yes.
there a way, you know how, like, in a quadratic, by checking the discriminant, all the number of solutions, is there something like that?
Is there a way to quickly check how many solutions there are in a cubic? Not so much. Yeah. Okay. Only one root, aka solution. What that means is this cubic will equal this cubic at only one location. That's what it means. Let's take a look. I'm going to put this in Desmos once again. Here we go. Y equals, what was the first one? 2x cubed minus 5x squared plus x minus 10. This was our first curve. Let's see if I can make that any bolder. Let's put that as 5. Okay, you see it? Everyone see it? And I'll fix this. How about I go from negative 20 to positive 20. Everyone's good, right? Here is a left equation. So that was equal to x cubed minus 2x squared minus 7. Turn that. Let's use orange and dotted lines. And let's make that dotted lines bigger too. Can't quite see it, but they're sort of spooning with each other, except to a single point. We have minus 10 to 10. Take a look. In this curve, there's only one location where they will intersect with each other, and that happens to be x equals 3. Okay, and is that the x-intercept? No, it's not. 3, 2. This equation is not talking about x-intercept. This equation is talking about when does the left side equal the right side. What's up? Please be careful. When I ask you the question solve, that's what it means. What is the x value that makes this true? If the one side does equal a 0, great. We can use our factoring skills. But we always got to bring this solution back to the original question. Okay, so I don't know, should we do a therefore? Let's call, if I'm gonna just, for the sake of it, I'll call the left side f of x, I'll call the right side g of x. Therefore, f of x equals g of x at only one location, which is x equals 3. Yes?
Question like this. Do you want us to write it like after the last one we wrote, like left side equals right side?
Oh, that's for a proof. We're going to do identities today. I mean, not today. We're going to do identities this year. That's a very specific genre, and there's a format for it. So leave that. But I like how you remember it. Example 3. Oh, yes.
So does that mean that x equals 3 is an x-intercept?
It is not an x-intercept. Well, here's the thing. Doesn't it look like an x-intercept? Why does it look like an x-intercept? Because we manipulated the equation. We turned it into a question that looks familiar. That's why I said, hey, is that familiar? Use your past skills. You worked really hard to learn your factoring stuff all the way from grade 10. Now we're going to throw it away? No. The reason why it was learned is because you can do this pretty much throughout your university. Set it up to one side, making the other equal to 0. Make it look like you're looking for x-intercepts. But when you find that value, it's actually referring to the original. This question and that question. So this one and that one have the same answer. That's essentially it. Example 3. Let's do this quickly. I see a lot of people starting to get a little tired and dreary, but that's okay. Quadratic formula. I am going to go about factoring this for you, and there will be times you get a quadratic, power of 2, and you can't factor it. So you go back to your grade 10 and 11. Here we go. Solve. Once again, when does this equation, so for what x is this true? I will factor. This becomes, you know what, I'll factor out a negative. Oh, they're all multiples of 4 as well. I'm going to factor out a negative 4x, which leaves me with positive cubed plus 6x squared plus 9x plus 2. Already, I have 1, 0. Okay, I have one x-intercept. Let's move on. This needs to be factored. Let me test it. you're going to test what? Plus minus 1, plus minus 2. Again, I'm taking for granted that you sort of understand integral zero theorem, that you're looking at the last ones if I want to factor. So I'm going to test the 1. Positive, 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 positive. That's not going to be a 0. Let's test negative 1. Negative 1 plus 6 minus 9 plus 2. Is that right? That's 8. No, that's not. Gonna make a mistake? Negative 1, positive 6, negative 9 plus 2. That's not equal to 0. Okay. F of positive 2, that's just going to make this number huge, so it can't be a 0. Negative 2, negative 8, positive 424, negative 18, plus 2. That equals a 0. We found it. So I will not do long division. I am going to 1 synthetic. See how the question's getting a little long now that we're in cubic, huh? All these skills, we're applying it. 1, multiply. Add, multiply. Add, multiply, and we get 0. Very nice. Which means, oops, which means, therefore, the equation is now negative 4x, x plus 2, x squared plus 4x plus 1, no remainder, equals a 0.
Just be negative 1 on the end there. And synthetic.
Negative 1?
Yeah, 2 plus negative 1 equals 0.
2 plus negative 1. No, that's a 2. So negative 2 times 1, that's a 2. Sorry. Okay, can I go further? I'll write this for you. But can I go further? You'll have to test it. Yeah, you'll have to test it. You don't know if there is more x-intercepts. So, so I think Katie was asking, is there a way to test very quickly for cubics if there's factors or not? No, but you can use your skills from grade 11. Anyone know the shortcut to see if there is or not using discriminant? Who has heard of discriminant? Okay, most people. I'm going to just quickly say this then. Okay, let's write this out. Let's test it. If you want to see if there are roots in, without doing too much of a calculation, I'm going to test the discriminant. Negative b squared minus 4ac, which is, what is my b? Is a 4. So 4 squared is 16 minus 4 times 1, 1. Okay. So that is, ooh, root 12. It does exist. Oh, man. Okay. Nice. All right. And not only does it exist, there's 2 of them. 4. X is equal to negative b plus minus the discriminant over 2a, which is negative 4 plus minus 12 over 2 times 1. And I'll save you the calculation. Negative 4 plus minus root 12 all over 12 is going to be negative 0.27 or negative 3.73 or something like that. So a question like that is going to be worth a significant number of marks because I expect you to do all of that, right? Therefore, the x values are that, so x values that make it's true, make equation true are 0. We also tested negative 2. We also tested and found negative 0.27 and negative 3.73. And of course, in this technological age, we can just confirm and plug that into the graphing technology. I'm sure they will give me a graph. Okay. The last one I want to do is I'll chunk it so that you see what each part is. The last question is very long, and something like that could be like a thinking question or a very difficult application question. It gives you a function and then gets you to plug in a y value and so on and so forth. Okay, so if you're done, I'll save the sheet so I could upload it, but if you're done.
On the discriminant part, what does that say in the bracket, like 1x1?
No, it's 1 times 1.
Oh,
one bracket, 1 bracket. Okay, just take a look for it online, okay, if you're sort of behind on those. Yes?
What point do we know that, when did you figure out that 0 makes this statement true?
What point?
Yeah, just the possible x values, 0, negative, blah, 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 where 0.
Well, oh, here. So it's a bracket, a factor times a factor times a factor. So your goal is to try to break this down into as many of these factors as possible. If I plug in a 0 here, that bracket becomes a 0, and anything multiplied by a 0 is 0. And so that's where I got that one from. Should I make a note? Would it help?
It's okay.
So this is negative 4x equals a 0, so x equals 0. X plus 2 equals 0, so x must be negative 2. So I want to do it with this, but I can't. That's not factorable. So we use our grade 10 quadratic formula skills and figured out, oh, decimals actually work.
Are those exact?
Exact enough. If I were, let's say, Ms. Jones, or one of our esteemed retired teachers, I would prefer that you do this instead, which is more exact. In fact, now that I look at it, I can reduce it. 4 divided by 2, so negative 4 divided by 2 is 2, and root 12 divided by 2 is like root 12 divided by 4 inside, so that's negative 2 plus minus root 3. Oh, you're wondering how I got there?
Yeah.
Okay.
I understand how you got negative 2.
It's good exercise. That's what happens.
Why over 4?
Okay, never mind. Would you agree that this is true?
Yeah.
4 over 2, negative 4 over 2, and root 12 over 2. Okay. 2 is equal to root 4. And because of that, you can say it's root 4 over 2 plus minus 1 big root 12 over 4, which is a 3. I know it's a little funky, but those are, it's radicals that we have learned in grade 11. I don't know if you've kept your grade 11 notes, but I know you've done it. Just have to refresh your memory. Okay? If you're having trouble, I can totally go through all of that with you again, but we'll have to do it outside of class. I'll put a little highlight there. Okay. I'm going to try to chunk it and give you an opportunity to try this super hard one on your own. Turn the page. I give you an equation for a height of a roller coaster. Okay, some of you might be copying. Height of a roller coaster. And I want to know something about between its domain 0 and 30 seconds. Between 0 and 30 seconds, when is this roller coaster at a height above 24 meters? Seems a little weird, but let's try it. Now, I am going to help you by giving you a factor after this, okay? Let's try this. Please set this up. Give me an equation that includes this and that idea. Since I'm talking about this as a domain, I don't have to worry about anything else. What would that equation look like? Height of 24 meters. It's referring to the y value. And so, essentially what you're doing is 24 is the height. When is it going to be greater than 24? Negative 0.001 t to the power of 4 plus 0.059 t to the power of 3 minus 1.19 t squared plus 9.4 t. This is painful, Mr. Kim. I know. I gave it to you intentionally. Now, we haven't fully covered how to work with inequalities. We are going to have a lesson on that Thursday and Friday. For now, I am going to get you to pretend or figure out when is this roller coaster equal to 24 meters, and then we'll be able to interpret it after we sketch a graph. Okay? So, here's the question. How would you solve it? Take a look at example 2. Left side equals right side. How would you solve that? Yeah, make one side equal a 0. Why would you put yourself through that suffering when you already have tools to use? Make one side equal a 0. If you can help it, that is, right? I'm actually going to go one step further. I really don't like this negative 0.0001 or whatever. And the other side happens to be a 0. So I'm going to just divide out a negative 0.001, leaving me with a coefficient of positive 1. Negative 0.059 divided by, Positive 0.059 divided by a negative 0.001 is going to give me a negative 59 t squared, t cubed. Negative 1.19 divided by negative 0.001 is a positive 1190. Following suit, that's a negative 9400. Oops, I forgot a t squared. And this is negative 24 positive now, 0, 0, 0. The numbers are very big, but at least I don't have any decimals anymore. So now we have to factor. What would you do? Take a look at example 3. You have an equation with one side equaling 0. What did we do? How do we factor? Yes?
Find factors of 24,000.
Find factors of 24,000. Okay, go. No, I'm just kidding. I'll give it to you. Let's try 5. Okay? I'll tell you right now, for the sake of time and your sanity, when you plug in a positive 5 equals a 0, therefore x minus 5 is a factor. Okay? I'm just going to give that to you. What I'd like you to do, though, is do what we did in example 3. Please use synthetic or long division. Tell me what the next factor form is. Good. I'll give you just a few minutes. Do it casually, no stress. It's a good way to practice what you've done in your quiz too.
After we have the synthetic or long division, we just do it again.
What do you think?
Sure.
Well, are you in a better position? What do you have so far in doing so? After you did this, what do you have in front of you?
1x into 11, slightly smaller equation.
Slightly smaller. That's not bad. Is it progress?
Yeah.
Good. So now we have, based on this, x minus 5, and then x cubed minus 54x squared plus 9. Oh, shoot. It's t minus 5, t cubed minus 54t squared plus 920t minus 4,800 equals a 0. Now we're better. We are in a better situation. Is there more? If there is, where do you look? We have this nice factor. We're done. We don't want to touch that. What about this? Are there any zeros for that? Quillen? But where am I looking? Okay, so find factors of 4,800. I'll give you it to you for the sake of time. If you plug in a 10, you'll realize it's a 0. In other words, t minus 10 is a factor. Okay. So once again, let's use the newly found equation. We've got 1, negative 54, 920, and negative 4,800, and there's a 10. 1 band, 10. Add band, 10. Add 480, and 10, 4,800, that's a 0. Which means I have t minus 5, t minus 10, and then t squared minus 44t plus 480 equals a 0. And yes, you might imagine we could do synthetic again for a quadratic, but based on your practice of quadratic, you can do product sum. There are two numbers that will multiply to 480, but will also add to negative 44. Thus, it is negative 20 and negative 24. In other words, t is 5, 10, 20, and 24. What are you talking about? Are you saying that at 5, 10, 20, and 24, I have a curve that does this? What are these numbers referring to? Yes, thank you. These numbers are referring to the original question. So let me zoom out for a second. This question is referring to, I'm going to draw a really, really intense arrow. Okay? It's referring to this. These answers, yes, these answers are the answers to that question. But it is also corresponding to the same answers as our original equation. Always go back to what you were starting with to answer your question. And so what does that mean? It means, go back to the original, when the height is at 24 meters. If this was my roller coaster, so therefore, let's see, a degree of 4, it is upside down. It's probably going to look something like, so let's pretend that's 5, that's 10, that's 20, and that's 24. It's probably going to look something like something like that. No, what am I doing? Yeah, or something like that. Something here, here, and I don't know if it goes down. Something here, and something there. At time equals 5, 10, 20, and 24, the height will be equal to 24. So using this graph, you can say, when is it above 24? Between 5 and 10 seconds. Between 20 and 24 seconds. I'll finish off with this sentence saying, therefore, I see you, Gabby, 1 second. The coaster is above 24 meters between 5 and 10 seconds and 20 and 24 seconds. Yes.
When I was doing the factor for the t squared minus 44t, I got negative 20 and negative 24t. It doesn't have to be negative because like it's negative 44. That doesn't make sense to the question.
Say that one more time.
Like for that for t squared minus 44t plus 48. Both of the zeros that come from that have to be negative since there's a negative.
Well, the numbers that we're using are negative inside the factor.
Yeah.
So you always think, okay, if that factor is equal to 0, that means it has to be a positive.
Oh, yeah.
Right?
Yeah.
So the factor, it looks like a 0, but you always take that factor and set it to equal a 0 to solve. That will give you the x-intercept or whatnot. Okay? That's it. Now we did a lot. That was jam-packed. Today's lesson is all about looking at a question and identifying strategies. Essentially, you need to be able to do things without me breathing down your neck. That's all it is. So the questions that are assigned even on this sheet are going to get you to notice strategies. Look at it, you're like, what could I do? Look at it, what could I do? And if you are memorizing things still, well, it will be a little challenging for you because you're going to have to sift through your file in your head, in your brain, and be like, which one do I want to use? Others who are sort of understanding where this is going, you will see that you're doing the same thing again and again, but in different ways. So take some time today trying each of these in this chronological order from easier to harder, and see if you can develop an eye for the strategies today. Any questions? Let's give yourself a break. I think you deserve it. I'm going to stop this video and away we go.